Hello everyone, and welcome to 8.0, which is all about ratios and proportions, our very first section of chapter 8. And today's warm-up question is, what is a goal that you have for the new year? We are trying to eat at home more, and so I'm trying to learn how to cook instead of going out to eat for every meal. So we'll see how that goes in 2024. But what is a ratio? A ratio is just going to be a comparison. So it's going to be a comparison of two quantities, and you can write it in three different ways. You can write it as a fraction, A over B. You can write it with a colon between A to B, and that's how you say it out loud, A to B. So if you're looking at like wins to losses, or like the number of dogs to cats, that's how you say it verbally, okay? And this should always be in simplest form, and we also want A and B to be whole numbers. We're not going to write ratios when those values are not going to be decimals, okay? So that those should be whole numbers. A should be a whole number and B should be a whole number, and they should be in simplest form. So for example, if you had 4 over 6, to reduce that ratio, I would divide each of those by 2, and so you'd get 2/3. Again, I showed you all how to do this in your calculator today in class, and so if you're not sure how to do that, I know that those were easy numbers, but if the ratio is a little bit more complicated and you wanted to know how to simplify it, I can show you how to do that in class. Okay, so always in simplest form. So let's see how this pops up in an actual problem. If there are 14 boys and 10 girls in Miss Hall's fourth period, so 14 boys and 10 girls in my fourth period, they want to know what would that ratio be of boys to girls. Now notice that they have that same phrasing here, boys to girls, kind of like what we did up here, A to B. So we want to go in that exact order. So we'd say 14 to 10. I'm going to write it like this. You could also write it as a fraction if you want, either way. So 14 to 10 or 14 over 10. You could even do the word 14 to 10. But we just need to make sure that we reduce that. So what does that reduce to? 14 to 10 is going to reduce to 7/5. So for every 7 boys in the class that there are 5 girls. So that would be the fully reduced ratio of boys to girls in Miss Hall's fourth period class. Again, if you're working with an improper fraction and you are trying to simplify something and it's giving you a mixed number, ask me in class if you're not sure how to do it on your calculator, and I can show you. Okay? All right. If you watch Parks and Rec, then you will understand this, the references in this problem. If not, you can still do the math. So, Lil Sebastian is a mini horse. He's a famous mini horse in the city of Pawnee. And Lil Sebastian stands 3 feet and 2 inches tall. So he is 3 feet, 2 inches. We want to compare that to the flagpole in Pawnee. That flagpole is, how tall? That flagpole is 25 feet tall. And so we want to write a ratio, so it needs to be in simplest form, same units, whole numbers, comparing the height of Lil Sebastian, the sweet little mini horse right here, to the height of the flagpole, okay? And so right now, Lil Sebastian is in feet and inches, and the flagpole is only in feet. So I want them all to be in the same units, but unfortunately, I can't just take off his ears, chop off his ears and just say he's 3 feet. He's 3 feet and 2 inches. So there's no way to do that without making that a decimal. And so what we're going to do is we're going to convert everything to inches. And so to convert his height all to inches, I need to do 3 times 12. But don't chop off his ears. Yes, 3 times 12 gives me 36 inches for little Sebastian, but he had 2 inches of ears up here. So total, he's going to be 36 plus 2, which is 38. So little Sebastian is 38 inches tall. And the flagpole, I also want to be in inches, so I'm going to do 25 times 12, which is 300 inches. So now I'm going to compare. It says compare the height of Lil Sebastian to the height of the flagpole. So that's going to be 38 over 300. You could also do this as 38 colon 300, which simplifies to 19, I believe, 19 over 150. So for every 19 inches that Lil Sebastian stands, the flagpole stands 150. So again, you could have done this with the colons instead of the fraction symbol if you want. So what does it mean to extend something? To extend something means to make it longer, right? So it's still going to be a comparison, but instead of just comparing 2 quantities, we're going to compare 3 or more quantities. So we still want A and B and C to be whole numbers. We still want them to be fully reduced. And it doesn't just have to be a 3-part one, it could be a 4-part or more. So it could be A to B to C to D to E, all the way through the alphabet, plus some. But we want those to be in simplest form, and we want it to compare 3 or more things, because realistically, we don't always just compare 2 things. If you're looking at the sides of a triangle, there are 3 sides in a triangle. So there are 3 angles in a triangle. Oftentimes in geometry, we're looking at triangles, and so we might want to compare 3 things, or for a quadrilateral, 4 things. Only tricky part here is we want to make sure that we fully simplify each piece. So let's look at an example. A triangle has side lengths 14 centimeters, 24 centimeters, and 30 centimeters. So the first thing I notice is that they're all already in centimeters, so there's no conversions to do. We want to write an extended ratio. It's extended because it's 3 parts, comparing the sides. So 14 to 24 to 30. This would be final if it were fully simplified. Always should be in simplest form. But each of these numbers has a factor that I can take out greater than 1. And so what I want to do is I want to go through and find a GCF of these 3 numbers. So what number goes into all of these? What can I simplify all of these by? No, it has to be all 3 parts, not just 2 of them. So I know that 6 goes into 24, and I know that 6 goes into 30, but 6 does not go into 14. Okay, so let's keep looking. I do know that all of these are divisible by 2. So when I do that, I get 7 to 12 to 15. So this is more simple than before, and that is as simple as I can possibly make it. So that is the extended ratio for these sides. So my original, I'm going to call that the OG. My original pieces were 14, 24, and 30, and this is what it's simplified down to. That is in simplest form. Okay? Why does that matter? Well, in geometry, oftentimes we won't actually give you the side lengths of something, but we might tell you what the ratio, the extended ratio of the sides is. So if it says the lengths of the sides of a triangle are in this extended ratio, 4 to 7 to 9, that does not mean that this triangle, I'm just going to randomly draw one, has side lengths that are 4 and 7 and 9 necessarily. They could, but it has been simplified to 4 to 7 to 9, or maybe that's what it already was, and that was in simplest form. But immediately I know that that's not in simplest form, because they tell me that the perimeter of this triangle, so I always think SpongeBob SquarePants says bring it around town. That's what I think of when I think of perimeter. So all the way around, so here to here, and go back to here, all the way around town. Perimeter should be 60 centimeters. So when I add together 4 plus 7 plus 9, that's not 60, that's 20. So I know that I have taken the same amount of each of these, okay? I have simplified this. So here's what that means. 4 and 7 and 9 are not my original pieces. That is what it has been simplified to. So what were my original pieces? I don't know what I took out of each of them, but I know I took the same amount out of each of them. So I'm going to rewrite this as 4x to 7x to 9x. That would be my original. I've just simplified it down. 4 to 7 and 9 is my simplified version. Okay? So what do I know about 4x and 7x and 9x? Well, if it has a perimeter of 60, I can go 4x plus 7x plus 9x, whatever all 3 of those original sides are, should add up to 60. And this equation allows me to combine like terms, because when I put all of those together, 4x plus 7x plus 9x, that is 20x. So if 20x equals 60, then what is x equal to? X is equal to 3. And why does that help me? Because if I know what x is, I get to plug that in to the original, 4 times 3 to 7 times 3 to 9 times 3. Those are going to be my original side lengths. So I'm going to do that math. That's 12 to 21 to 27. So my original side lengths were 12, 21, and 27. And those do, in fact, have a perimeter of 60 when I add them all together. So this is the original, were 12, 21, and 27. Those were the side lengths. That just reduced to 4 to 7 to 9. So we were actually able to find unknown pieces using the extended ratio given and knowing that the perimeter is 60. Okay? The measure of the angles in triangle ABC have this extended ratio of 1 to 2 to 3. Again, this is the simplified version. 1 to 2 to 3 is the simplified version. And it says, find the measure of the largest angle. So I don't know what these angles are, but I know that the way that they relate to each other is 1 to 2 to 3. So one trick on this problem is it doesn't give you a magic number like it did on this problem. On this problem, it gives you that the perimeter is 60. It doesn't give you necessarily what all the angles should add up to, the measures of the angles in the triangle, but we know from last semester that the measures of the angle of any triangle should always have a sum of 180 degrees, no matter what it is. So I know that this had to have been reduced because 1 plus 2 plus 3 is 6, which is not 180. So I'm going to throw an x next to each of these. I have taken the same amount out of each of these pieces of this ratio. And I'm going to say, okay, well, I know that 1x plus 2x plus 3x should have a sum of 180. And then I can just combine some like terms. So if 6x equals 180, then x equals 30. That helps me find all of these pieces, plugging them into this ratio right here. So 1 times 30 to 2 times 30 to 3 times 30. So what were my original pieces? I had a 30-degree angle, I had a 60-degree angle, and I had a 90-degree angle. The answer to the question is going to be, what is the largest angle? The largest angle is going to be 90, and then the medium angle would be 60, the smallest angle will be 30. And you can check yourself to make sure you did that right by adding those up and making sure that they add up to 180. So this is a 30, 60, 90 right triangle. Okay? So sometimes you have to think through the problem in order to know what to add them up to. Okay? All right, the measures of, now we're just working with a ratio, not an extended ratio. The measures of two supplementary angles are in the ratio of 1 to 4. 1 to 4. What is the measure of the smaller angle? So again, we think that this might have been reduced because I know that they would not be supplementary if it was 1 plus 4. That would just be 5 degrees. Supplementary means that they should add up to 180 degrees. So I'm going to go 1x plus 4x, and I get that 180 by knowing that supplementary angles have a sum of 180 degrees. So if 5x equals 180, then x equals 36. And why does that help me? Well, now I can take this and actually plug in what x is. X is 36, so that's going to be 1 times 36 to 4 times 36. So the smaller angle would be 36 degrees. The larger angle would be 144 degrees. So if they ask me for the both pieces, that's what I'd give. But they only ask me for the smaller, so the smaller is going to be 36 degrees. And those are, in fact, supplementary angles. All right, we talked through this in class, but we just talked about how the way that somebody sets up a proportion might be different, but there are equivalent proportions. So a proportion is just an equation setting two ratios equal. So I'm setting A over B equal to C over D. So this one ratio I'm saying is equal to this ratio. Okay. So here's how you can create some equivalent proportions, properties of proportions to remember. If somebody were to do the reverse and set it up as B over A instead, that is totally fine if they flip that pink fraction, as long as they also flip that blue fraction. And we're going to look at why that works in a second. And you can also switch one set of the diagonals. You can switch one numerator and one denominator. Swap diagonally. So if I left B and C in the same spots that they're currently in, I can switch the D and the A, and that will still be an equivalent proportion. Or I can leave the A and the D where they're currently at, and I could switch the B and the C. And we'll look at why this works again in a second. So I'm going to say or. This works because whenever you cross multiply, remember when we solve proportions we cross multiply, this is A times D, and that's going to be equal to B times C. When I cross multiply these two, that's still going to be A times D equals B times C. You're still doing the same cross products. Same thing here. That's going to be A times D equals B times C. So when you end up cross multiplying, even if you set it up different than someone else, we have equivalent proportions that will still give you the same answer. Okay. Other than that, we just went through some practice of actually solving for a missing piece of a proportion. So what we're looking for is what value of x can go here to make the that fraction equal to a ratio of 5/4. So we're just going to cross multiply. I'm going to do 6 times 4, and I can set that equal to 5 times x. So we get 24 equals 5x. 24 is equal to 5x. So I'm going to divide by 5 on both sides, and when I divide by 5, I get 4.8. So x would have to have a value of 4.8 in order to be in the same ratio as 5/4. So 6 over 4.8 equals 5 over 4. I like to go back and look at it and make sure that that is smaller on the bottom like this one was. This went 6 to x, 6 to 4.8, did get smaller, just like 5 to 4, because that would be a really obvious way to recognize that you had made a mistake if not. Okay. We only did one more of these just because y'all did a lot of this in middle school. So we talked about what happens when you have more than one thing. Instead of just being written as A over B, this part has some extra stuff. And so I told students I am 31 years old, and still to this day when I cross multiply, I always throw a set of parentheses around binomial expressions, ones that have more than one thing going on. Because now when I cross multiply, I will not forget. I'm not just doing 3 times y, I'm doing 3 times this entire thing. So I'm going to have to use some distributive property. And then I set that equal to 9 times y. And so that's just the distributive property. So I'm going to distribute the 3y plus 12 equals 9y. I get my y's on the same side, so I get 6y. So y is 2. Check yourself before you wreck yourself. That is the answer. It just says to solve for the variable. I'm going to go back and plug it in and make sure that makes sense. If I plugged in a 2 here and a 2 here, let's see what happens. That is 6 over 9. Is that, in fact, equal to 2/3? Yes, it is. So I know that I did that correctly, I should say. So you can look at the answer key or come see me if you need help on these next two, but just practice those. I believe when I solved them earlier, if you want to try them just as a test, I got 63 on this problem, and then I got 1/4 or 0.25 on this problem, just to see if you did it right. All right, and then here was our exit slip. Pause the video here and try it, but I am going to write the answers that I got when I worked these earlier. This says width to length, so your answer would be 23 to 42 here. Whenever you do equivalent proportions, a over 13, so they went numerator over numerator, equals denominator over denominator. That'd be 7 over b. And they did the inverse of a over 7, which is 7 over a. They flipped it. That's the reciprocal. So they'd have to go b over 13 here. Okay? And then when you cross multiply on this one, you should get z equals 12. So here is your homework, and try it, and we will see how you do tomorrow. Hope you have a wonderful day.